Good day everyone. Welcome back to my YouTube channel. I am Jovian Hiraldo, a BS EdMath 2A from Kapalong College of Agriculture Sciences and Technology. Kung bago ka pa lang sa channel ko, please do hit subscribe and click the notification bell for more updates and for more upcoming videos. For today's video, we are going to discuss linear programming. A linear program can be solved by multiple methods. In this section, we are going to look at the graphical method for solving a linear program. Before we proceed to our main content of this topic, I just want to share you a quote from Dr. APJ Abdul Kalam, saying that don't fear for facing failures in the first attempt, because even the successful mathematics start with zero only. These statements say that everyone knows that the first step never gone good, and it is also challenging for us, but we never give up. It is not easy, but we have to make it easy. Overcome fear of failure. Without further ado, let's get started by defining what is linear programming. So linear programming is one of the simplest ways to perform optimization. It helps you to solve some very complex optimization problems by making a few simplifying assumptions. It also used to find optimal value of objective function. We attempt to maximize or minimize a linear functions of the decision variables. Linear means all mathematical functions are required to be linear, while programming refers to planning, not computer programming. It is the process of selecting the best solution from various alternatives. So to sum it up, linear programming may be defined as the problem of maximizing or minimizing a linear function which is subjective to linear constraints. Next are the process to formulate a linear programming problem. So first, we are going to identify the decision variables. The decision variables will decide the output. It gives the ultimate solution of the problem. For any problem, the first step is to identify the decision variables. So second, we are going to write the objective function. In a problem, the objective function should be specified in a quantitative way. It is defined as the objective of making decisions. Third, mention the constraints. The constraints are the restrictions or limitations of the decision variables. They usually limit the value of the decision variables and should be expressed in the mathematical form regarding the resource. Lastly, explicitly state the non-negativity restrictions. For all linear programs, the decision variables should always take non-negative values. This means the values for decision variables should be greater than or equal to 0. So we already defined linear programming. Now, what is graphical method? Of course, it is one of the LPP method and used to solve LPP involving two decision variables x sub 1 and x sub 2. A graphical method involves formulating a set of linear inequalities subject to the constraints. Then the inequalities are plotted on an xy plane, just what you see in the picture. Once we have plotted all the inequalities on a graph, the intersection region gives us a feasible region. The feasible region explains what all values our model can take, and it also gives us the optimal solution. The feasible region explains what all values our model can take, and it also gives us the optimal solution. We also have the steps for graphical method. So first, formulate the problem. It is for objective and constraints. Second, frame the graph. Third, plot the constraints. Fourth, plot the graph. Fifth, outline the solution area which satisfies the constraints. 6. Circle potential solution points. It is the intersection points of all constraints. Lastly, substitute and find optimized solution. Let us take an example. Our problem is a farmer Jovian has recently acquired a 110 hectares piece of land. She has decided to grow cardava and binangay on that land. Due to the quality of the sun and the region's excellent climate, the interproduction of cardava and binangay can be sold. She wants to know how to land each variety in the 110 hectares, given the cost, net profit, and labor requirements according to the data shown below. So we have two types of variety, the cardava and binangay. The cost price per hectares of cardava is 100. The net profit still price per hectares is 50 and the labor is 10. While the cost of binangay is 200, the net profit is 120 and the labor is 30. The farmer Jovian has a budget of 10,000 and the total number of Mondays is 1,200. Now, we are going to solve this by identifying the decision variables. Let the total area for growing cardava is equal to X, this is in hectares, and the total area for growing binangay is equal to Y, also in hectares. So obviously, X and Y are her decision variables. Step 2. Write the objective function. Since the production from the entire land can be sold in the market, Jovian would want to maximize the profit for his total produce. We are given net profit for both cardava and binangay. The farmer earns a net profit of 50 pesos for each hectares of cardava and 120 pesos for each binangay. So therefore, our objective function given by z is maximum of z is equal to 50x plus 120y. Step 3. Writing the constraints. It is given that Jovian has a total budget of 10,000 pesos. The cost of producing cardava and binangay per hectare is also given to us. We have an upper cap on the total cost spent by her. So our equation becomes 100x plus 200y is less than or equal to 10,000. The next constraint is the upper cap on the availability of the total number of Mondays for the planning horizon. The total number of Mondays available is 1,200. As per the table, we are given the Mondays per hectare for cardava and binangay. So we have 10x plus 30y is less than or equal to 1,200. The third constraint is the total area present for plantation. The total available area is 110 hectares. So the equation becomes x plus y is less than or equal to 110. Step 4. The non-negativity restriction. The values of x and y will be greater than or equal to 0. This goes x is greater than or equal to 0 and y is greater than or equal to 0. We have formulated our linear program. It's time to solve it through graphical method. Since we know that x and y is greater than or equal to 0, we will consider only the first quadrant. To plot the graph for the equation, first I will simplify all the equations. 100x plus 200y is less than or equal to 10,000 can be simplified to x plus 2y is less than or equal to 100 by dividing by 100. Next, 10x plus 30y is less than or equal to 1,200 can be simplified to x plus 3y is less than or equal to 120 by dividing by 10. The third equation is in its simplified form. So we still have x plus y is less than or equal to 110. So now, let's plot the graph. The optimal feasible solution is achieved at the point of intersection where the budget and Monday's constraints are active. This means the point at which the equation x plus 2y is less than or equal to 100 and x plus 3y is less than or equal to 120 intersects gives us the optimal solution. The values for x and y, which gives the optimal solution, is at 60 and 20. To maximize profit, the farmer should produce cardava and binangay in 60 hectares and 20 hectares of land respectively. Therefore, the maximum profit Jovian will gain is maximum of z is equal to 50 times 60 plus 120 times 20. So this equal to 5,400 pesos. So now we're done. The problem is solved. This is the importance of linear programming. When you have a problem that involves a variety of resource constraints, linear programming can generate the best possible solution, whether it's maximizing things like profit or space, or minimizing factor like cost and waste. Using this tool is a quick and efficient way to structure the problem and find a solution. That's the end of our video for today. Don't forget to like, share, comment, and subscribe to my YouTube channel. Thank you for watching, guys. Bye!